Many ancient caves have signs and symbols on their wall that may represent substances or animals or emotions. Early alchemists represented sulfur, zinc, gold, silver, mercury, lead, copper, iron, tin, and bismuth, as shown here. Dalton represented the elements by these symbols: hydrogen, carbon, oxygen, phosphorus, sulfur, magnesium, lime, soda, potash, strontium, iron, zinc, copper, lead, silver, gold, platinum, and mercury. Modern chemists represent the elements by these symbols. The symbol represents an atom of an element and is indicated by one or two letters. Hydrogen is represented by H, whereas chlorine is not represented by C, but by two letters, Cl, Y. Because C represents carbon. To avoid any confusion between carbon and chlorine, we have taken two letters, C and L, for chlorine. In case of two-lettered symbols, we keep the first letter alone in uppercase. Calcium is represented as Ca. Barium is represented as Ba, but sodium and potassium are represented as Na and K, because they were derived from the Latin words natrium and kalium, respectively. According to IUPAC, the International Union for Physicists and Chemists, elements can be named after a mythological concept, a mineral, a place or country, a property, or a scientist. For example, the element californium is represented as Cf. The name is derived from the state and the University of California, where the element was first synthesized. The molecular formula of a compound represents the number of atoms of elements present in a single molecule. For example, hydrogen gas is represented as H2. The ammonia molecule is represented as NH3. Water as H2O. Sulfur dioxide as SO2. And sodium hydroxide as NaOH. Let's consider the water molecule. The atomicity of hydrogen is 2, and of oxygen is 1. But the combining capacity of oxygen is 2, and that of hydrogen is 1. Molecules are formed based on the combining capacities of their constituent elements. The binding tendency of an element is called valency. The word valency has been derived from the Latin word valentia, meaning strength or power. Elements, by combining with each other, attain better strength and stability. Let's assume valency to be like a hook. Hydrogen has the valency 1, that is, it has a single hook. Oxygen has the valency 2, a double hook. Let's visualize how these two elements combine to form a water molecule. We can easily identify the valency of an element based on how many hydrogen atoms it could combine with or displace in a chemical compound. Look at this table. Since chlorine combines with one hydrogen atom, its valency is 1. Nitrogen combines with 3 hydrogen atoms, and so the valency of nitrogen is 3. Similarly, the valency of carbon is 4. Since many elements combine with oxygen, the valency is conveniently defined as twice the number of oxygen atoms with which one atom of the element will combine. There is a simple method to indicate the valency by crossing the arrows as shown here. For example, the valency of carbon is 4 and that of hydrogen is 1 in the methane molecule, CH4. A radical is a group of atoms of different elements which behaves as a single unit. Example, sulfate, represented by SO4 2-. Like elements, radicals also have valencies. The valency of the sulfate radical is 2. These radicals are also represented with charge and valency. Radicals with negative charges are called acid radicals, and with positive charges are called basic radicals. Monovalent radicals have the valency 1. Examples for monovalent basic radicals are potassium, sodium, copper 1, and ammonium. Examples for acid radicals are nitrate, hydroxide, chloride, hydrogen carbonate. Note that basic radicals have positive charges and acid radicals have negative charges. Divalent radicals have the valency 2. Examples of divalent basic radicals are iron 2, lead 2, zinc, calcium, and barium. Examples of acid radicals are oxide, sulfide, sulfate, sulfite, and carbonate. Polyvalent radicals have a valency of more than 2. Examples of polyvalent basic radicals are iron 3, aluminium, phosphorus 3, and phosphorus 5. Examples of acid radicals are phosphate, nitride, and carbide. Some radicals can exhibit variable valency. For example, iron can behave as iron 2 and iron 3. Such radicals are named by specifying the relevant valency in parentheses. We can write simple molecular formula by combining the acid and basic radicals. Let's combine monovalent basic and monovalent acid radicals. We have to adopt a few steps to write a molecular formula of the given compound. Step 1. Identify acid and basic radicals and write down their symbols. Step 2. Write down their valencies. Step 3. Cross over their valencies as subscript to the radical symbols. Step 4. We need not write valency 1. We can simplify the crossover numbers to write down a molecular formula. Let's combine monovalent basic and divalent acid radicals. Adopt the same steps. Step 1. Identify acid and basic radicals and write down their symbols. Step 2. Write down their valencies. Step 3. Cross over their valencies as subscript to the radical symbols. Step 4. We need not write valency 1. We can simplify the crossover numbers to write down a molecular formula.